Good afternoon, everyone. Today we are going to study about database, fundamentals of database. Before learning SQL, machine learning or data science, it is important for us to understand what is database, because database is where all the data is being stored and managed. So first of all, let's understand what do you mean by data. Data is a collection of raw facts and figures. For example, we have name. Name is equal to Jyoti. Say age is equal to 35. City is equal to London. If you take that example, if I say if it is only Jyoti, it does not have any meaning. Or for here example, take this example, name, age, salary and temperature. If I say name is just Jyoti, it does not add any sense. Or if I say any salary figure, it doesn't add sense. But if I take all the figures, for example, take all these variables. If I say, oh, today the temperature is about 30 degree, my name is Jyoti, I'm 35 years old, I earn a salary figure of 1 crore. That makes sense, right? Rather than just saying, oh, Jyoti. What Jyoti means? Jyoti what? You don't know. So, what we know that data, what we collect, that is the name, age, salary, these are all the raw facts. And when we process these raw facts, that becomes an information. When we process this raw facts and come to a meaningful data, and that becomes information. For example, again, let's take another example. Say we have collected the name Jyoti. Say we have collected her age group 35. Her education has master. Then her job profile, you can say data analyst. We can say the experience is about 6 years. So when you comprehend, when you put together all that itself gets an information. But if you just consider as its own, it doesn't add any information. So what is the difference between information and data? Data is a collection of raw facts, and with these raw facts we analyze and come to a meaningful sentence that we call it as an information. I hope you have understood what is the difference between data and information. So next thing, before we do anything, let's learn about the data life cycle. What do we do with the data? So the data life cycle consists of creating the data, collecting the data, storing the data, processing the data, analyzing the data and deciding the data. Now in the above example, we already know that we collected the raw data, we collected the raw data, we stored them in the electronic, say in the file, in the book or elsewhere, and then we processed the data. And once we processed the data, what did we do? We analyzed it and then we came to a meaningful conclusion. So that is what the data life cycle is. So in the data life cycle, in the data in the data life cycle, what do? We collect the data, and once we collect the data, what we do? We store them. We need a place to store. We store the data, and once we store the data, we analyze. This data can be used anywhere. It can be used for anything, like for business analysis, or say to develop a machine learning, anything. So we can use this data and then we analyze for the business purposes. So we use something called CRISP DM framework. The pipeline is, first of all, we understand what the data is, we collect the data, we analyze the data, we build the models, and once we build the model, that we use it for the business purposes. So now first thing, let's talk about the creation. How do we create? Before we talk about the create, we will see how to collect the data. How do we collect the data? The data can be collected from anywhere. It can be collected from software, or it can be collected through research, or it can be collected from the internet, or it can be collected from the some survey, or and from any study purposes we collect the data. As we said, once we collect the data, what we do? We store the data and then we process it. Process it in order to get the meaningful information. Then we analyze and then we decide what decide to take. For example, say we have a bank data, okay, where we have the customer service, customer ID, we have the customer's age, we have the customer's profession, then we have the bank account. So from bank account, from this data we could analyze what? Analyze the person's age group, then that will give the customer's age. Or we can analyze the credit score to decide whether to give the credit for that particular person, or what sort of customers are we getting into our banks, or what sort of customers we are dealing with. So these are all the data where we collected it, we stored it, and then we have used it in the meaningful way to make any decision, whether it's a business decision or whether it is a health decision. So this is about the data life cycle. So next one, why do we need the data? We need the data. First of all, the main important of the database is we need it for storage. It should be easily storaged. It should be easily retrievable, easily searchable, analysis and record keeping. As I said, once the data has been collected, what happens is we need a place to store. Otherwise, without storage, it doesn't make sense. So in database, it stores we store a large amount of data. Retrieval means it's easily should be accessible. There is no point of saying, oh, that this record is lost, or that record is lost, or this record is misplaced. That shouldn't happen. So it should be easily retrievable, and once we do the retrievable, we can analyze the data. We can use it for anything, analyze the data or make the decision. And then as a record keeping, as you know, we have to also keep the track of the records. For example, here let's talk about the hospital here now. In the hospital, we have thousands of data, and finding the data through the paper files, it would be very difficult. We imagine when we were students, when we had to get the patient record, we had to go into one storeroom, and then we have to hunt the file, looking each file, looking for the patient's name, detail. So it takes a hell lot of time. So to prevent this shortcomings, we have, that's the need, we should store the data, or we need the database. Now, exactly what is the formal definition of database? A formal definition of database here is, it is an organized and structured collection of logically related data which is stored in the electronically stored. So first of all, it is an organized, structured collection of logically related data. So let's understand by the each term what is organized, structured collection or logically related data. Now here we have is we have something called organized data. What do you mean by the organized? Organized means arranged properly. It is stored in the format way. For example, here most of the data, it's divided into two parts. We have what is that called? I forgot now. Structured data and unstructured data. Structured data means what? It is always meant in the tabular form, like in the table form, where we have enough rows, we have columns. So that is called as structured data. For example, say we have let's collect a customer's ID. Okay, so we have a customer ID as one column, date of purchase is one column, type of product he has purchased is one column, and then we have what is that, price of the product, who was the seller. So we get a overall picture of that particular data. So that is called as organized data. Then structured means it is a predefined format, like as I said that in the predefined format is we there's a format, like in the tabular form. So that is called as a pre-structured format. Logically related means we should be able to connect to each other. For example, now we have the data, one table. For example, let's say we have one table of the customer, we have another table of the product. Okay, the type of product, the customer ID, the product ID. Now when we have comparison of 2-3 tables, we should able to get a relationship, then you call it as logically related. Let's take one another example. Say we have a database of movies. Okay, and in the database there are thousands of tables. For example, say we have one table of a director, one table 2 of the producer, and table 3 of the cast. So in that we have one in table 1 we have movies name, we have a director, and we have the actors who are associated with that particular film. In the second table, again, we have the movie name, we have a producer's name, we have total profit that is being made through this film. And then in the third table, we have again the movie's name and the cast or the actors who have worked in that particular team. Now we want to find the director. Okay, which director has the highest earning or the success rate? So how do we find? We have 3 tables here. So we connect the table. How do we connect the table? We connect the table with the common row or the column. Here we have in the table 1, the common name we have here is cinema name or the film's name, and then in table 2 also we have the film's name. We have a director name in table 1, we have a producer in table 2, we have the film cost, how much is it. So if we join the table and then we can come to know, oh, say Rajkumar, or for example, let's say, okay, Rajkumar has the director. He has directed this film called which one we can say, Vande Matram, for example. Okay, and then this film has made about 3,000 crores. Or say the new one, the Durandar, the film. It's been acted by Ranveer Singh, and the production has gone, I don't know, say 2,000 crores or something, or 200 crores or something you can say about it. And then we know, yes, this director Ajit Dheer is the best director, so you want to perform another project with him. So this is called as or logically related data. So another one, again we can say, patient has an appointment, he comes to the doctor writes the prescription, and all these prescriptions are linked. So that's what it means, logically related or connected data. Then, what is a database? We have already studied. It is an organized, structured collection of logically database. We have already seen what is structured logically data. Now, let's talk about the Properties of an ideal database. What should be a property? First one, it should be accurate, because if it's not accuracy, we won't be able to do anything. So the first thing is it needs to be accurate. Secondly, there should be consistency. In consistency, what happens? Whatever data we add or whatever data we going to add or added, the consistency of the data should remain the same. For example, we have say rows and columns. The rows and columns should remain the same. It should, whatever data we have added, it should be in the row, it should be in the column. So the rows and the data, it shouldn't be changed after the adding the column or before adding the column. So the integrity of the data should remain the same. Then the next one we have is integrity. Integrity again, it should remain same. Security, it should be secure, because without security these days it's not ideal. And also it should be easily accessible. So what are the properties of an ideal database? It should be accurate, consistent, integrity, security, and easily available. Then what are the advantages of database? Advantages of database, here again, it is accessible anytime, 24/7. It's accessible. It's very fast. We can get the data in a minute. For example, when we want to add something, or when we want to get the patient's information, so we just add the patient's ID number or date of birth. We can easily get the data electronically. So it is called as fast retrieval. Security, again, it is well secured. If the PIN number and all we keep it secure, then nobody can easily log into the data. And obviously it reduces duplication. So these are the advantages of database. That is, it is easily accessible, fast retrieval, it is secured, and reduced duplication. So now let's talk about the types of database. In types of database, we have is the relational database. In relational database, all the structured data in the tabular form is being saved. For example, we have is one of the example is Excel. We store the data in Excel in the tabular form, but Excel has a limitation because we cannot store the large amount of data. There's a cutoff limit, like for about 10 or 10 lakhs or about about 10 lakhs, so I'm not sure, or 1.6 lakhs, I think. I'm not very much 10.5 or 16 lakhs. It has an what is that called, limit. So we cannot store large amount of data. Whereas in relational database, what happens is we can store large amount of data. So it is easily retrievable. Second one we have is NoSQL. In NoSQL data, what do we do? The data here handles all the unstructured data. Unstructured data means it handles all about the videos, images. So these sort of data are handled by NoSQL database. The third database we have is the column database. Here there is no rows. The data is only stored in the form of column. So that's why we call it as column database, and it is suited for the warehouse or analytical application. For example, we have Amazon or Google by query, where they analyze the products. It is easily available. If you want to find the average, you have the columns easily, and it is much faster. So that is called as column database. Then the third one we have is the graph graph database. In the graph database, what do we do? uh, in the graph database, we store all the structured data in the form of graph. So that is called as graph database. And the last one we have is the key value database. Key value database again is stored in pairs of pair. For example, in the form of dictionary, where you can see the JSON database is one of the example of key value database, where example you have how can I say, okay, we have key is a one word, and key 2 or say key 1 belongs to Jyoti, so that is one pair. And the second one, key 2 belongs to Claudie, that is the second pair. So this is how it is stored, and this sort of arrangement we call it as dictionary in Python, and this form of arrangement you form it in the JSON form. So these are all the types of data where the data is arranged according to the business need. Now, here we are more focusing about the relational database, because in the relational database where we are going to use more of our SQL commands, so we are going to understand what is relational database. Relational database is stored again in the form of rows and column. And here in an as you can see in an Excel, we always know that there is lots of rows and columns. We have the horizontal, those are called columns, sorry, the horizontal one are called as rows, and the vertical we call it as column. So this is about the relational database, where it is consist of rows and column. And for example, again we have student table, ID, name, age. These are all represented by one student. So each row, for example, we have ID, say ID1, ID2, ID3. So these represent the IDs of individual student, followed by name and age. So, and in SQL, okay, in SQL we call the rows as field, where sorry, the rows as record or tuple, and the columns is called as field, and the number of records we call it as cardinality of relationship. It is called as what? Cardinality of relationship. And the number of field or columns or attributes, we call it as degree of relationship. I hope you have understood. So, as I said again, the NoSQL handles unstructured, custom, semi-structured data, as we have seen example, social media posts, text, images, all that. And this is about the column database. Here you can see, I think I've already explained you all this, what is column, what is key value database, I have explained. And I've also explained now what do you be a relational terminologist. We have already discussed about that. Next we will study about the CRUD operation. In the CRUD operation we have create, that is insert. We create a table, then we read the table or we select the table, then we have update operation and delete operation. So these are all called as the CRUD operation. And in the CRUD operation we have one more called ACID. ACID means A stands for atomicity. Let me see whether I have that one in my database. What is atomicity? No, I don't have it. So let me explain to you. A stands for atomicity. So what happens is, all these CRUD operations, what we perform, it actually all happens at once. It doesn't happen, oh, after 5 minutes or two. It all happens once. And that is why it is called as atomicity. So that is A. C stands for consistency. As we have explained earlier, consistency means the structure of the data before and after adding the table. It should remain the same. I is isolation. Isolation means what? Now there are hundreds of people performing the same operation, but the same operation is considered as different operations. For example, we have is the PayPal or Razorpay. Hundreds of people are doing number of transactions, but the transactions are all totally different. They are not related to each other, and that is why we call it as isolation. Durability. D stands for durability. Durability means even if the system fails or system is gone down, the transaction, all the records are kept safe. It's not lost. So that is called as durability. So the database should support the CRUD operation. In the CRUD operation, we have also spoken something about ACID. That is, A is atomicity, C is consistency, I is isolation, and D is durability. Now, having studied all this, the next one we are going to study is what is DBMS. Now we have understood what is data, what is types of databases. You have understood. We have understood why database is necessary, what are the advantage. So here we are going to study the next thing. We are going to study about the DBMS. What is a DBMS? It is a software system that provides the interface and tools needs to store, organize and manage data. So what it is? It is a software that provides what? That provides the interfaces and tools that is needed to store, the organize and manage the database. So we will understand this slowly, step by step. Now most of the time here what happens is SQL versus Python. SQL is what? SQL is used for database, whereas Python is used for what? Programming and analysis as well. And here we can say, for example, now here we in Python, what do we need? We need a Jupyter notebook, a Google platform. It needs a platform to write the code. So likewise in data SQL, we have MySQL as the database where we write the query. Query is nothing but it is called structured query language. In Python we call it as programming, but in database, in SQL, MySQL is a platform, and the SQL what we use to write the query is called as structured query language. And lastly, this is recap about the data. We have seen what is data, what is database, DBMS, SQL. So I hope you have understood this topic in short, and I appreciate if you could give me some formal feedback. Thank you.